Hi guys, welcome back to my channel. In this video we're going to be discussing prime factorization. All it really means is to write numbers as product of prime numbers. But before we do prime factorization, we need to know what prime numbers are. The answer is they are numbers that can only be divided by itself or 1. What it really means is that prime numbers can only have 2 factors, and the reason I say 2 factors is because in the definition before it said that a number is a prime if it's only divisible, which means it can only be divided by 1 or itself. But that means the same thing. 1 will be the first factor and the number itself is the second factor. So the two definitions can be interchanged and they will mean the same thing. So all you need to remember is prime numbers can only have 2 factors, and factors are numbers that divide whatever number it is factor of. So let's take a look at an example here. I'm going to show you 2 numbers. One of them is a prime and the other one is not a prime. So let's take a look at our first number. So 5. We know 5 is a prime number because only 2 numbers multiply together to give us 5, and that is 1 and 5, because 1 times 5 give us 5 and nothing else multiplied together give us 5. But let's take a look at 9. 9 is not a prime number, and it's not a prime number because it obviously goes into 1, it goes into 9, but it also goes into times table of 3. So let's have a look here. 1 times 9 gives us 9, but 3 times 3 also gives us 9, so that's 1, 2, 3. So that's 3 numbers that give us 9. Therefore 9 is not a prime, whereas 5 is, because only 1 can divide 5, or 5 can divide 5. No other number, or to be specific, no other whole number can divide 5. Try these questions to see if you understand which numbers are primes. Pause the video and then play again to see the answers. So let's take a look at all these numbers. Now I'm going to show you the solution. Like I said earlier, that a prime number only has 2 factors. And the reason is every number is going to have 1 as a factor and itself as a factor. That's why a number that is prime will only have 2 factors, or a number that only has 2 factors is a prime. So let's take a look at number 10. We know 1 times 10 will give us 10, so every number automatically has 2 factors, okay? It's just a matter of fact. If it has more factors than 1 and itself, then it's not prime, but if it only has 1 in itself, then it is prime. But in this case, 2 times 5 also give us 10. So that means we've actually got 4 factors. Therefore, 10 can't be a prime. So let's take a look at 7. We know 1 times 7 will give us 7 because every number definitely has 2 factors. 1 and itself. Does it have any more? No, it doesn't. Therefore, it is a prime. 13, 1 times 13 gives us 13. Does it have any more? No, it doesn't. Therefore, it is indeed a prime. Number 15, well, 1 times 15, yes, will give us 15. But are there any combination of numbers that give us 15? Yes, that's 3 times 5. So in this case, we've got 4 factors of 15. Therefore, it can't be a prime. because a prime number can only have two factors, which is 1 and itself. But in this case, because 3 and 5 are also factors of 15, therefore it can't be a prime number. So let's get back to the main focus of prime factorization. All that means is that you get a number given, and all you need to do is write the number down as a product of primes. So we know what primes are now, I hope anyway. And all you need to do is write the number as a product of primes. The best way to do prime factorization is by doing a factor tree. So all that really means is take the number 24, find the smallest prime number. So smallest prime number in this case is going to be 2. And you say, what do you multiply 2 to get 24? So you do 2 times 12 to get you 24. And at any step where you find a prime number, you circle it. Then you look at 12, because 12 is not quite a prime. So you do the same step that you did for 24. So find the smallest prime number that goes into 12. Again, you can write 2. And then it's 2 times 6 that give you 12. And because 2 is a prime at this stage, so you can circle 2. Then we look at 6 and do the same step for 6. So we know 2 times 3 gives us 6. But in this case, we know that 2 is a prime and 3 also is a prime. And we can see we've gotten to the end of our tree, and we know we've gotten to the end when both the numbers are primes. So in fact, the prime factorization of 24 is all the circled numbers. So it's 2 times 2 times 2 times 3. There's a shorter way of writing this, and it is 2 to the power of 3 times 3. So 2 to the power of 3 because you've got 2 3 times and then times by 3. So let's have a look at 30. 30 goes into 3 and 10. But we know 3 is a prime number, so we can circle that. 10 is not a prime number because it's got more than 2 factors. So we find another prime number, and in this case we can have 2 and 5. But we know that 2 is a prime number, and we know 5 is a prime number. And we're at the end of the tree because we can see both the numbers have been circled. Therefore, 30 can be written as a product of its primes, which are the circled numbers. So that's 3 times 2 times 5. But at every stage, you need to be careful. Whenever you're doing a branch, the two numbers need to multiply to give the number above. So 3 times 10 gives 30. And in this case, these two branches are coming off 10. Therefore, we needed to find two numbers that multiply to give 10. So let's take a look at 144 now. I'm going to do this one slightly differently, and you'll see how in a second. So 144 I know is 12 squared. Therefore, it can be written as 12 times 12. 12 times 12 give 144. This is the last example, and I'm going to do this slightly differently. You see how in a second. So 144 is 12 times 12. But you can clearly see at this stage you can't circle either of these numbers because 12 is not a prime number. So we just continue our tree and we say, okay, 12 is 4 times 3. That obviously can be the case here as well. But in this case, I'm going to pick a combination of two different numbers. I'm going to pick 2 and 6. Okay? And at this stage, I can circle some numbers. So in this branch, we can circle 3 because 3 is a prime number. And in this case, we can circle 2 because 2 is a prime number. And 4 is 2 times 2. So we can circle both the 2's and we've reached the end. Therefore, for this part of the branch, we can stop. Whereas 6 can be split into 2 and 3. And we know 2 is a prime number, and we know 3 is a prime number, and we can see at the end both of these are circles, so this is where we can stop. The reason I chose different ways of dividing 12 differently, the only reason why I chose 12 to be divided differently in these cases is because I wanted to show that it doesn't matter what combination of numbers you use, as long as it multiplies to give you whatever number that you desire to get. It shouldn't really matter what your answer is at the end because it will be the same answer. So let's forget the 144. Let's write down 12. Well, 12 will be a combination of 2 times 2 times 3. And according to this tree, it will be 2 times 2 times 3 is 2 times 2 times 3. So we've got 2 2's in both of them and 1 3 in both of them. So it doesn't really matter which way you go. So it doesn't matter if you decide to do 4 times 3 or 2 times 6. At the end, you will get the same answer. So it doesn't matter as long as the final answer is a product of primes, because in fact you are trying to do prime factorization, which means writing the number as product of its primes. So in a similar way, 144 can be written as either 12 times 12 or 2 times 72, but in the end you should get the same combination of prime numbers. So let's take a look at our answer here. So 144 actually equals 2 times 3 from this part here, and then 2 times 2 times 3 again, 2 times 2 times 3. There's a shorter way of writing it, and that is 2 to the power of 4, because there's 4 2's, and 3 to the power of 2 because there's 2 3's. So this is your final answer.